let's make the class more interactive, okay? Because we don't want like only I am talking, you're listening to me. It's not like that. Am I audible perfectly?
Yes, sir.
Yes. Okay. So okay, now look at this. Today we'll understand a topic called motion. Okay. The chapter is today we'll discuss from motion. And let me just open the board. Okay. Let me open the board for you. Is this board visible? Hello? Is this visible? The whiteboard is visible?
Yes, sir, we can see it.
That's what. So we learn a topic called motion today. Okay. So what is your understanding about motion? What is this topic is all about, and how do we understand that a product is in motion? Can somebody tell me how do we understand a product is in motion?
When it's changing its state, like
When it's changing
when it
its
travels. State.
what
When
state?
travels.
So maybe a product from hard to liquid, is it in motion? If a
No,
product
sir.
if a product changes its presence from a hard products, okay, from a hard material to liquid material, is it in motion?
No, sir.
Then what do you say that?
When it travels, sir.
Travels. Okay. Okay, see
Changes its
that.
position.
Sorry.
When it changes its position.
Okay, see that. A car is moving in front of us. Okay. A bus is moving in front of us. All right. All right. So, what do we call rest of us? Like, what and all we can take? Any other movements? Change in position with time. Any item changes its position, whether it is an object or a material or a man or anything. Any kind of objects change its position with the time. Okay. We call it motion. So what we can say, the definition, we can say change in position with time.
Respect to time.
Change in position with the time. For example, by you stayed in a particular place on a particular time and you moved 2 steps forward or 2 steps backward, or you are gone to the left side of it or right side of it, wherever you are there. You are standing from there, you went to a left side or right side or front or backward, whatever. So change in position. Okay, change in position with the time. So if you ask someone, if you ask anybody to you, like what is motion? Change in position with the time. Can you all write this concept? Motion equal to change in position with the time. Change in position with the time. All right. Which means what? Means the object in motion. The object in motion. So what I wanted, after completion of this class, I will be asking you few questions, okay? I'll be asking you for a few questions. Whoever is clearly concentrating will only be able to understand. But what I want is, once we complete this chapter's few areas today, you don't have to study this again in future anywhere. I want you to learn that way. You got me? I want you to understand in that way that this chapter is just like that, without notes, it is clear to you. You understood? Without having notes for future, you are just clear in these topics. Is that clear with you, my dears? Any trouble in understanding? Meera, where are you? I can't see you, Meera.
So 1 second, I'm charging.
My camera is not.
2 seconds.
Yeah. So, hope all of you noted this. So, what I mean by when an object changes its position with the time, it is said to be in motion. You got me? Daksh. Motion means what? change in position with the time. Is that clear?
Yes, sir.
Okay. I have next concept. My next concept is this. Okay. What I'm telling you, motion of object is always, okay, is always with respect to a very big word, frame of reference. What I mean to say here, motion of an object, okay, motion of an object is always with respect to a frame of reference. So somebody asks you, what is frame of reference with respect to motion? What this can be? What is this frame of reference here? My dears, what is this frame of reference here? Can anyone tell me? What is this frame of reference? Huh?
So there are probably some forces that act against an object.
No, come again.
There are many forces that they're responsible for the motion of an object.
No. Any other? Try. Aditya, try. What is frame of reference? Have you heard about this word frame of reference earlier? Have you heard about this frame of reference earlier? Have you heard about this, Meera? Himani? No. All right. So, suppose you are sitting in a bus. Okay, let's take that. Suppose you are sitting in a bus. All right. So you sit in a bus and you turn back or you see in front, and a lot of people are sitting with you. Okay. I mean, you observe them. Everybody is in rest. If you turn back and see, if you see in front side or left side or right side, if there are many people are sitting, you can observe that all of them are in rest. All of them are in rest. Am I right? Or they are moving. They are moving, or they are moving backward or front, or are they in motion, or they are sitting? What is happening? Are they moving, my dear? Or the bus
Yes,
is
it,
moving?
it's
The
moving.
bus is moving.
The bus is
Everything else
moving.
around it.
The bus is moving, but the passengers are not, who are sitting with you are not moving. They are in rest. Am I right? Bus
Yeah,
is
they
moving.
are.
Now slightly open the window and see outside. What happens? What you observe?
We are also moving with the bus, and
Then you feel that you are moving with the bus, or you feel that there are a lot of trees and houses, buildings are just traveling backward.
useless. Very bad.
What is happening? What do you observe?
What?
We are moving with respect to the surrounding, but with respect to the bus, we are not moving.
Are these trees are moving? What do you observe?
Trees are not moving, but it seems like they're moving because the bus is moving.
Bus is going forward. So when you observe that, or you feel that the trees are moving, am I right? Trees are
Relative
moving
motion.
backward. Am I right? Trees are moving backward. Am I right, my dears? Trees are moving backward. So what I'm trying to tell is, now if you come out of the bus, you stand in a bus stop. Okay. Suppose you're standing in a bus stop. Okay. Are you all with me? Okay. Suppose you're standing in a bus stop and there are so many vehicles. Suppose you see a bus is passing in front of you, an auto rickshaw is passing, a car is passing in front of you. Likewise, many vehicles are passing in front of you. So what you see that are all these vehicles are in motion? All these vehicles are in motion. Am I right? Yes or no? All these vehicles are in motion. Am I right? Yes or no?
Yes.
So from where you are observing this motion? From where you are observing this motion? Might just tell me from where you are observing this motion. Suppose when you are standing at bus stop and you see that a lot of vehicles are passing in front of you, moving in front of you, at what point you are watching this motion or observing this motion?
Point of reference.
Ah, that particular point is called frame of reference. You got me what I'm saying?
Frame of reference is nothing but point of reference.
Correct. Point of reference equal to frame of reference, which means motion is always with a frame of reference. Or motion can be observed only from where a frame of reference. Now you understood what is frame of reference? Okay, now who will tell me, give me what you have understood. What is frame of reference? Himani, tell me what is frame of reference now. What is frame of reference now? What is frame of reference?
So frame of reference is like when the object is in motion, but then in reference to a point, we say if the object is in motion.
Oh, I was on mute. I'm sorry, I was answering.
Good, Meera, very good. Where is Neerav? I can't see him so far. Jayasimha, what is frame of reference?
So his camera is not working.
Who's Neerav? Okay, Jayasimha, what is frame of reference?
Sir, I don't know.
Sorry? What is frame of reference? Who can give me? Neerav was good. Who else can tell me what is frame of reference? Who can tell me? I said motion from where you are observing the motion. Okay, from which point you are observing that motion, that particular frame or that particular area is okay. If you are observing a motion of from a bus stop, this particular area where you are standing is frame of reference. Okay, or it is called point of reference. Is that clear? Is that clear? Are you guys are still into something else or are you listening to me?
So
My
one
dear-
second. Can you
Is that
repeat
clear?
what you said? Somebody came.
So I am telling about motion frame of reference. This is nothing but motion is always relative with reference to frame of reference. Okay, a quote. Motion is always relative with reference to frame of reference. You got me? Understood? Any doubts? Do you want to copy this? Motion is always relative with reference to frame of reference. Okay. Motion is always relative with reference to frame of reference. Okay. What chapter we are learning now? Ideas, what chapter we are learning?
Motion.
Motion. Okay. Next word is called rectilinear motion. Okay. Rectilinear motion. Have you heard about this word earlier?
Yes, sir. When you
What?
move in a straight direction.
Wonderful. So what happened? Motion along straight line. Motion along straight line. What does rectilinear motion mean by? Motion. Any object is moving in straight line, it is called rectilinear motion. Okay? Any object moving in a straight line is called a rectilinear motion. So what is rectilinear motion? An object, if an object is in travel on a constant line, okay, on a straight line, okay, this object, suppose a car is moving on this direction, okay, on a straight line, this is called rectilinear motion. Are you all clear now? What is rectilinear motion? Motion along straight line. Is that clear? Understood? Okay. So now since rectilinear motion has come, what can be circular motion?
Motion along a circular path.
What? So of course, now two type of motions we are able to understand. One is rectilinear motion, other one is the circular motion. Okay. So circular motion is any motion circular. Okay. Any motion in circular format. Okay. Is called circular motion. Is that clear? Okay. Now till this point, what and all we have learned till now? Who can tell me points, point wise? First, what I told you.
What is motion?
Okay.
Then then you explained that motion is always with respect of frame of reference.
Wonderful. Next.
And then we did then what is frame of reference, and then rectilinear motion, and then circular motion.
Very good. Very good. So you keep noting down all the points what I'm discussing. Good. Next. Okay. Next point is describing. Okay. Describing motion of an object. Motion of an object. How to describe an object is in motion? Okay. What we need to do, we need to always consider position. Okay. Position changing with the time. Okay. The point at which the object is located at a particular instant. Okay. See what happens is here, change in position. Describing motion of object, we need to always consider position changing with the time. So time you should not forget. Okay. An object was there at A position at a particular timing. Okay. And B position. Suppose we take, okay, let's take a person. Okay. Let's name a person here. Let's take a person name. A boy name is Bonnie. Okay. Let's see. Bonnie travels from A to B. Okay. Bonnie, what he does? He travels in his bicycle. Suppose he is traveling in bicycle. All right. He travels at, for example, at 9 a.m. he was at A position. Okay. And at 9:15 a.m. okay, he was at B position. Okay. Understood? So what is the time taken here? From A to B, what is the time taken? From A to B, what is the time taken? 15 minutes. Change in position and time. You got me? From 9 a.m. to 9:15 a.m. 9 a.m. he was at the position of A. 9B he reached to B in 15 minutes time. Probably if this is 4 kilometer. Okay. The distance is 4 kilometer. Then what has happened? From A to B, he has traveled 4 kilometer within a time of, or within the time limit of 15 minutes. Change in position with respective to time and distance. Okay, my dear. Now distance also came here. You got me what I'm saying? Is it boring or are you able to understand?
No, sir, we can understand.
Could understand, right? Are you able to follow with me?
So,
Yeah. Right? So next point is, let us understand few physical quantities of this topic. What we are going to do, we're going to understand few physical quantities. Okay. Anyway, when we are learning physics, after all, we have to understand the concept behind each heading to be understood, each topics to be understood. After understanding the topics, we need to understand the concept behind that topic, and then it mathematically to be proved, right? That's the way it goes physics. Am I right? Then those physics concept has to be proved mathematically. So to get into mathematically, let us understand two physical quantities of these topics. The physical quantities, okay, physical quantities of these topics. The physical quantities are, one is path length. Other one is, okay, displacement. What are the two physical quantities? Path length and displacement. What you understand or what you have heard about this word called path length?
Could be the distance.
Distance. Okay. And
Length of the path.
displacement?
It is the fastest route toward a particular destination.
Fastest route or shortest route?
Shortest route.
Ah, correct, na? Easy. You mean to say that it is the easiest
Yeah,
route?
shortest.
It is easiest or shortest route. Am I right? The shortest route. So let us understand this two topic in a different way. I said path length. So let's see this path length and this displacement you will learn in 11th standard in a bigger way. Okay, you have to keep this in mind. 11th standard, this topic is in a bigger way. It will come to you. Okay, it's really huge topics. So let us understand what is path length here. Path length is basically, okay, we can take it in this way: distance of an object, distance of an object, okay, distance of an object, okay, distance of an object travels from initial to final position. Okay, we call it in a short form total distance. So what is path length is? Distance of an object travels from initial to final position. Okay, an object is traveling, okay, A to B. So this distance, okay, this distance, can we take it as this distance? Yes or no, my dears? Distance of an object travels from these two distance. So here, let us understand. Have you all copied this? Copied?
Yes. Yes.
Okay. Let's see. Suppose we have Boni here. Okay. Boni from home to school. Okay. The total distance home to school is, let's take about 4 kilometers. Okay. Now Boni from home to school, the total distance is 4 kilometers, which is the shortest one. From home, Boni went to a friend house. Okay. Now from friend house, he went to his grandma's house. Okay. Then from there, he goes to school. Okay. Let's take from home to friend, it is another 4 kilometers. From friend to grandma's house, another 6 kilometers. From grandma's house, another 10 kilometers to school. So what is the displacement here and what is the path length here? What did happen? Boni from home to his school he wants to go. Okay, the actual distance from his home to school is only 4 kilometers. But then what did he do? He's a bad boy. He went directly to his friend's house. Then from there he went to grandma's house. He spent some time there. Then he took a way to school. So that way is probably 10 kilometers. Here it is 4 kilometers and here it is 6 kilometers. So what is the total displacement and the path length?
The path length is 20 kilometers.
Path is how much?
20
20.
kilometers.
And displacement?
4 kilometers.
4 kilometers.
4 kilometers. So the shortest distance, okay? Shortest distance is what? Displacement. Displacement equal to shortest distance. You can write down. Displacement equal to shortest distance. Path length is equal to total distance. Are you writing? What I said? Displacement equal to shortest distance and path length equal to total distance. Is that clear, my dears?
Yes, sir.
Okay. So now let us understand few next quantities. Have you heard about scalar and vector?
Yes, sir.
Okay. So what is the difference between scalar and vector quantities?
Scalar is independent and vector is independent.
Yeah, scalar is without direction and vector is with direction.
It's not
Very good. So
only
scalar is with magnitude. Am I right? And vector is magnitude plus direction. Okay. Suppose I give you a bike. Okay. I'm telling you I'm giving you a bike. And I told you that just drive this bike with an 80 kilometer per hour speed. Okay. For next 1 hour. Is it scalar or vector?
how
I said
scalar?
I am giving a bike. Okay. I am giving a bike. I told you take this bike, run this bike for next 1 hour with a kilometer speed of 80.
It's scalar quantity.
Why is it scalar quantity?
There is no
There's no
direction
distance.
mentioned.
I haven't told you where to go. Am I right? I haven't told you where to go. So suppose I told you, if I would have told you actually take this bike, drive for next 1 hour within a kilometer of 80, maintaining 80 kilometer per hour speed and go to from Ooty to Coimbatore. Okay. Then it is vector quantity. Am I right? Yes or no? Whether temperature is a vector or scalar quantity.
I'm sorry, sir.
Temperature.
I think it will be a scalar quantity.
Scalar, because there won't be any direction mentioned for temperature.
Then why do they say Coimbatore is morning it is 28 degrees Celsius and Ooty is morning is 12 degrees Celsius?
Because
There's
it's
no
at
direction.
that particular place. It's not given a direction that.
They did not mention north, west, or something like that.
They don't mention anything.
Altitude is different, so it will be different only.
So let us say temperature is talking about a specific area on a particular day. Am I right? So it is we can take it as scalar quantity. Am I right? Avantika, can you sit properly? I'm able to see your knees. Yeah, that's good. Okay. So sit properly in the class. So scalar, it is what actually? Scalar quantity. What is scalar quantity? I said temperature. Am I right? Temperature, isn't it? Yes or no, my dears? All right. So speed is a scalar quantity. Whether speed can be scalar quantity? Is
No,
speed
sir.
a scalar quantity?
Speed is yes, scalar quantity.
Why do you think? Can somebody classify why speed is a scalar quantity? Dipender, open the camera here. Let me see you. Dipender Mittal, keep your camera on. My
Yes,
dears.
yes, sir.
See, what I
So
wanted
It
to
does
tell
not
you was
include direction.
wait. What I wanted to tell you is that, like, actually, okay, a teacher, when his teacher is talking, if I can see all your face, okay, when we are in a small frame of reference, we are talking. So when I can see your face, I'll be much happy to deliver more things to you, okay, more content to you. And if you ask me more things, then the class will go more interactive and any areas of doubts can be clarified about our topics. Right. So let us make the class enjoyable. Let's not take it as a burden. Let's take it as enjoyable. Ask me. We are discussing one of the fantastic topics of physics. Motion is very, very interesting topics. When you go to 11th standard, the motion itself derived in 2-3 formats, like motion in 1 dimension, motion in 2 dimension, rectilinear motion, projectile motion, and motion in a plane. Okay, so many things will come. So this motion basics understanding of motion in 9th standard is very big, very, very big. Okay, here is the pillar. The pillar makes in this class. Okay, only then your building will be strong. You understand? The pillar is made here in this class of motion. Then you build a building over that pillar. It will be very strong. All right. So we are discussing whether speed is a scalar or vector quantity. Speed is a scalar or vector quantity. Who can tell me?
Can I answer?
Yeah.
Speed is a scalar quantity.
Okay, then velocity.
Velocity will be a vector quantity
Why velocity is a vector quantity, my dear?
because it's speed with
Because it
direction.
has direction.
Okay, it talks about direction. Is it talking about direction?
Yes, sir.
Okay, which means how do we classify? How do we, can you give me an example of speed and velocity?
So, for example, if a boy is traveling for 10 kilometers,
Hmm.
but so that would be 10 kilometers for at a speed of 40 kilometer per hour. So that would be a speed because there is no direction mentioned. But
Okay.
if he travels at a speed of 40 kilometer per hour towards east or west, then that would be the velocity.
Good. Good example. Very good. Okay. So now you have understood the difference between speed and velocity. I hope so. Right? Shalom. Okay. The next point is what I want to tell you is okay. Before we do the numericals of this chapter, all the basic concepts and derivation to be understood. Okay. Only then I will be teaching you the numericals, problem solving areas. Okay. With the equations, like we have to learn. So, in some cases, path length and displacement are equal. What I'm trying to tell you, okay, what I'm trying to tell you is, in some cases, path length and displacement are equal. Can this possible? Can this be possible? In some cases, path length and displacement are equal. Can this be possible?
Yes, sir.
How?
Yes, sir.
How?
Could it be in rectilinear motion?
No. Anything else? Think. Path length,
For
what we
example,
understood about path length? Path length is what?
the distance of an
Total
object
distance.
which travels from in
Path length is total.
No, what is
initial
path?
position to
Total distance.
final position.
Suppose let's take Boni, okay?
Yes, sir.
Boni from home to his school, okay,
Yes.
it is 4 kilometer.
Yes, sir.
Okay, if he's a good boy, he goes directly to school. Okay,
So it will be the same displacement.
it will be the same thing. Suppose he go directly to the school, then what happens? Okay, he don't roam anywhere. He has not gone to any other places, and he has not gone to his friend's place. He has not to his grandma's place. He has not gone anywhere else. He directly went to the school and he returned back. Okay, so in this case, what happens? Our displacement and path length can be equal. So when you do the problems, numericals, you need to understand this word especially, okay? How the person has traveled. Is he traveled directly or he has traveled all the other places? You got me? You got me? How path length and displacements are equal, Avantika?
Yes, sir.
Yeah, how path length and displacement are equal? In what condition it can be equal?
When
Vanishka?
when the path is straight.
No. Vanishka, can you tell me?
Sir, it's Varshika, sir.
Sorry?
Nothing, sir. So displacement and path length, they are equal in some cases. Suppose, as you told right now, Boni is going to home, from home to school and coming back. So that can be total distance also. That is
If
fine.
a person take a direct travel to that on the desired travel route on the desired exact distance. Okay, if a person travels on an exact distance on a decided route, okay, in that time actually what happens? Path length and these things can be equal. Okay, am I right? Right. Next condition is that you understood, right? How path length and displacement is equal, that you have understood. Now, if path length 0, okay, and displacement is also 0. Can this be possible?
It is in rest, sir.
Can this be possible? Can path length be 0,
Yes.
displacement is 0?
Yes, sir.
How?
When the object is in rest.
Still the object would have been traveled
When the
somewhere,
object is
right?
at
So
the
if the
distance,
object travels, if
Object
the
travels, it
object
starts.
starts off
So
from point
see,
A and returns to point A, it could be possible.
okay, Yutika, an object travels from A to Z. Okay. On the way, if he reaches to B, okay, you say that he is on rest here. Okay. That's what you try to say to me, right? The distance is A to Z. Okay. The object wanted to travel A to Z, but at B point it is rested, which means path length is 0. Path length is not 0. How path length is 0? Path length can only be 0 if an object is not traveling. Am I right?
Sir, I don't think that's possible. Path length and displacement both 0.
Yeah, sure.
See this. Boni. Okay. What happens? From home. Okay. He travels to school, which is 4 kilometers. Okay. Are you all with me? From home to school, he travels 4 kilometers. Okay. My dears. Now he traveled from home to school. While reaching the school, he understood the school is closed. Okay. The school is closed. So he returned back. Where?
Home.
To home. In this case, what is his path length and what is his displacement?
his displacement will be
Displacement
0.
is 0. Path length is 8.
Path length is
8.
8 kilometer. Displacement is
0.
why?
Because sir, he went to the school and he came back. So if you subtract it, it's 0.
And displacement is distance respected to the time. So
Displacement is the shortest
hovering
distance.
in.
So when he comes back at the starting and ending are the same. So it's 0.
Starting initial position, final position is same. Am I right? Initial position, final position is also so displacement is 0, but path length is total. He has traveled 8 kilometers. Am I right? Yes or no? You got me? Okay.
Yes, sir. I got it.
So next point is okay, speed and velocity. Speed and velocity. So this is basically related to path length and displacement. Am I right? Related to path length and displacement. What is speed? What is the definition for speed?
Speed is equals to
Distance by
distance by
time.
time.
Distance by time.
No. Is it distance by time?
Yes.
Are you
sir.
sure? So if I write
Distance covered in time.
path length by time, can I write? Can I write?
Yes, sir.
Yes, sir.
So, but what is the
So
definition?
speed is distance covered. How much
Speed.
distance is covered? Speed.
So that's what I told you, path length. Path length is equal to total distance. Previous slide I have told you, path length is equal to total distance. So the total distance by total time. So can I write definition for speed like this? Rate, okay, at which, okay, and rate at
It
which
is a
an
field of distance.
object covers distance. Rate at which an object covers distance. Definition for speed. Rate at which an object covers distance. So what happens here? On a particular time period, an object covers a particular distance. So you have given me the formula for speed. Speed is equal to total distance by total time or path length divided by time. I am talking about the concept or I am talking about the definition. What is the definition? Rate at which an
Rate of
object
change of
covers distance. Is that clear, my dears? Hope all of you are writing. I am not asking you to write specifically, but the good students, Whoever wants it, particular points to be penned down. Okay, you're all in 9th standard, you're not in kindergarten classes, so the teacher don't have to say to you, write down, write down, write down. Keep writing. Make it as a practice. Stop, write bullet points, only then you will be able to recall it later time. Am I clear? Am I clear, my dears? All right. So, can somebody tell me till now which are all the points we have discussed?
Rate which an object what?
Covers. Covering. Covering. Okay. COVERS.
Is speed.
Distance. Speed. Speed equal to rate at which an object covers the distance.
Okay, sir.
ठीक है ना? All right. So, next point, velocity. Am I right? Am I right? Velocity. So, what is velocity?
Sir,
The-
basically speed with the direction.
Rate of change of distance. Sorry, speed.
No. What is the formula for velocity?
Displacement by time.
Wonderful. Displacement by time. So, how do we write? Definition. Rate
Rate of displacement in respect to time.
which an object changes its position. है ना? Rate at which an object changes its position. So what is the difference between speed and velocity, my dear, according to physics? Other Aroda, can you tell me speed and velocity, the difference?
Speed is a scalar quantity, while velocity is a vector.
Wonderful. Next point. Speed is equal to path length divided by time. Velocity is equal to displacement by
time.
So in speed only matters. In velocity, position changing matters. Velocity, what happened? An object changes its position. Are you all with me?
Yes, sir.
Is that clear?
Yes, sir.
In velocity, what's happened? In velocity, the object changes its position. Speed means the speed is maintained. Total distance is maintained. Distance. Is that clear?
Yes, sir.
Okay. Let's take one example. Are you all with me? Hello?
Yes, sir.
Okay. Again, if Bonnie, travels 20 kilometer in 1 hour. Okay? 20 kilometer, 1 hour. What is the speed? What is the speed?
Distance by time.
So how much it is? 20 kilometer per hour. Isn't it? Okay. So Bonnie, now what happens? Suppose he travels 20 kilometer in 1 hour. Okay. In 1 hour west. Okay. He travels 20 kilometer 1 hour west. Is it velocity or speed?
Velocity.
Velocity. So velocity means what actually now? Equal to again 20 kilometer per hour towards west. You must write this word. Where did he go? 20 kilometer per hour towards west. Is that clear? Okay. So take the mall experience. Suppose he went to a mall here. Where did he go? He went to a mall, 20 kilometer. Okay. Mall is closed. He returned back to home. Now what is his speed? I said 20 kilometer he went and the mall is closed. He came back to home. Now what is his speed? I said repeatedly, don't keep your cameras off. So what is the speed now? Himani?
So the speed would be because he traveled back the distance. He would travel the distance would be 40 kilometers, and it would take him 2 hours to reach back home. So again, it'll be the same speed, 20 kilometer per hour.
So what is the speed? 20 kilometer plus 20 kilometer upon
Hmm.
upon 1 plus 1 hour.
Plus one.
Am I right? Yes or no?
Yes. Sir.
Correct? So yes or no? So this will be 40 divided by 20. Am I right? Sorry, 2. Am I right?
Yes.
Yes or no? Okay. So
Yes, sir.
in this case, what is velocity? Speed is, Himani, speed is 40 by 2. What is the velocity in this case?
The displacement would be 0 because he travels back.
Okay, so velocity?
So the answer would be 0.
20.
Displacement is 0, so velocity will also be 0.
Yeah.
When velocity is 0, displacement is 0. When displacement is 0, velocity is also 0. Am I right? Yes or no?
Yes, sir.
Okay. Now, have you ever observed some objects like this? Okay. I'll tell you some objects. This objects. Okay. Suppose a pendulum like this. Okay. And it takes to and fro motion. Have you ever observed an object like this? Have you ever observed some objects like this?
Pendulum, sir. Pendulum.
Pendulum is observed, right?
Yes,
So
sir.
in this, generally, speed will be more. Okay. Speed will be more. Okay. Object is moving forward and backward. Okay. What is happening? Moving,
Distance.
moving front and backward. Okay. But velocity? Velocity?
Will
What will
also
happen to
be more.
velocity? Velocity will be more or less.
More.
Why? Why velocity can be more? How this motion will be like this? Am I
I
right?
didn't understand.
Yes, sir.
Can you repeat?
Yes, this motion. See, the pendulum motion of pendulum will be like this. Am I right? Yes or no? Yes or no? So let's see, at particular point, if the pendulum stops, okay, it would have covered very less space from the starting position or from the final position, which means it covers very less space. So velocity will be less. In this kind of pendulum kind of experiment, velocity will be less, speed will be more. Okay. In this experiment, speed is more, velocity is less because started and reaching finally and starts to final position will be very less. Okay, less space. So which means when it is less space, velocity will be less, speed will be more in this kind of experiment. You got me? I am moving on to the next topic, next area called distance time graph. What about this word? Distance time graph? Have you heard about?
Yeah.
Yes.
Yes, sir.
Okay. So I'm doing it with free hand. Actually, if you're drawing it, you draw it perfectly in your notes. Okay. Draw this with a perfect note. Perfect scale, pencil and all if you have, you can draw it. So what I'm doing here, we are learning about distance time graph. Okay. So this axis, x-axis, I'm taking it as time. And y-axis, I'm taking it as distance. Okay, this is distance. So here, 1, okay, 2, 3, 4, and here I am mentioning 10 kilometer, 20, 30, and 40 kilometer. Okay. This side obviously -1, -2. Okay. Hello. Again, for example, Boni here. Okay. Boni travels to a mall first 1 hour, 20 kilometers. So how do I measure the graph? Here is 20 kilometer. So 20 kilometer, first 1 hour, 20 kilometer, second 1 hour. Okay. All right. Second 1 hour, again 20 kilometer. So next 1 hour, he reached to this position. First 1 hour I said 20 kilometer. Second 1 hour, again 20 kilometer. So how do we draw the graph of this distance time graph?
Sorry, sir.
How can we draw this graph? I said first 1 hour he travels 20 kilometer. Second 1 hour he travels 20 kilometer. So what will be the graph line?
10 kilometer per hour, sir.
So first 1 hour he travels. Okay. 10.
Yes, sir. Like this
Next
one.
1 hour, what did he do?
2 and 2.
40 kilometer. Am I right? Yes or no? So the graph will be a straight line. Am I right?
Yes, sir.
Yes
Linear
or
motion.
no? Okay. What motion it is?
Linear
Linear.
motion.
Can I take it as a uniform motion?
Yes, sir.
What is uniform motion?
Same distance and same time.
Like constant.
Yes.
Constant travel, that's okay, Mira. But what is uniform motion? Can we write like this? Definition: equal distance. Okay. Equal distance in equal intervals of time. Can we write like this? Definition for uniform motion. Uniform motion is what? Equal distance in equal intervals of time. With this graph, we can understand. First 1 hour, he traveled 20 kilometer. Next 1 hour, he traveled 40 kilometer. So total 2 hours, he has taken 40 kilometers. So for each 1 hour, he covered 20 kilometer equal distance. Am I right? Each
Yes,
1 hour,
sir.
he has covered 20. Am I right? So can we say this object was in uniform motion? Can we say this was in uniform motion? Hello?
Yeah.
All right. So why do we say this was in uniform motion?
Because it's equal.
It
Equal
is
distance and equal time.
very good. Equal.
Time and
See,
distance.
you should not forget equal distance and equal intervals of time. That's and whoever is told me, remember equal distance
But I
is,
just have a small doubt.
ask me.
Speed is always bigger than velocity, right?
When speed changes, velocity changes. When velocity changes, acceleration changes.
No, sir, but then is it greater?
Wait. I'll describe. Speed changes, velocity changes. When velocity changes, acceleration changes. And then
So, sir, in this changing, which will be the greater one? Like, what will
change
be
in
greater?
velocity happens only if acceleration changes. I have not taught you acceleration as of now. When we come to acceleration, you will understand that.
Acceleration.
So, but
Okay.
that pendulum thing, you said velocity was greater.
Velocity is less.
Oh,
In
it's
pendulum
less,
case,
okay. So speed is always greater, no?
speed is great. But you will understand now how this is related to velocity and acceleration related to speed.
Okay.
Okay? So, in this graph, what have we understood? We have understood two things. One is what actually? This is the graph of how a graph is to be drawn, distance time graph. Okay. This x-axis is time, y-axis is distance. Okay. In distance time graph, x-axis is time and y-axis is distance. And in this, we have understood a uniform motion. Why uniform motion? Because that person has traveled equal intervals of time, equal distance. Am I right? Yes or no, my dears? Is that clear to you? Okay. Suppose I say a slope here. Okay. Let's see. A slope here. Slope. A slope. What do you understand by slope? What you heard about slope? Or what you know about slope? What is slope mean by? Can I rub this? Hope you have copied this.
Yeah.
The slope is gradient, I think.
So now Avantika, before I move from this, can I ask Avantika what is uniform motion? Avantika, uniform motion.
Yes, sir. Equal time and equal distance.
Equal distance covered in equal intervals of time. Intervals of time. Okay. That you remember. That you have to remember. You understand? Okay. Now my question is here, this word, slope. Have you heard about slope? I'm telling you, I'll teach you one important area in this, which you would not have learned at all in your life, and no one would have taught you. And you will not forget me on this area. Okay? I'm telling you, slope is equal to speed. I'll prove.
Sir,
What I said, slope is equal to speed. Yeah, who's asking me something?
sir,
Yutika?
can we please have a break?
I'll give you, after stopping this, we'll go for a break. We'll just complete this slope alone.
Okay, sir.
Okay? 5 minutes, I'll complete this slope alone. Now you're going to understand something very interesting and better. In this motion chapter, I am telling you, slope is equal to speed. Okay? What I wanted to tell you, slope is equal to speed. Where is Daksh? I can't see him. Daksh, are you there?
I'm here only. My laptop is getting charged, so I can't stand like this. So.
ठीक है, just keep it open and listen to me. Okay. Meera, you sit. What is she doing?
Sir, I need to go to another place. Avantika needs to charge.
Just 3-4 minutes. We'll finish it off this and then you go. Or we'll continue with after break. Okay, we'll continue after break. When all of you go to break, come back, I'll teach. Okay? So don't switch off your videos and other things. Sorry, keep your videos off. Don't log out.
Okay, sir.
Yeah.
Sir, are you there?
Yes. Vanshika, tell me.
Sir, at 12 o'clock, can I go because I have my practice?
Not 12 o'clock. I will leave you by 12:15.
12:15. Okay.
Okay.
So can I like finish this topic and go?
That's what.
Okay.
Okay. So because now this will be a practice on every Sunday or what?
Yeah, most probably.
Can you request them to start by 12:30? Because I don't want you to miss in the
Sir,
class.
Yeah, the thing is the schedule has been already planned by the sir, by sir, so he can't change it.
You just request,
But
is
sir,
there any possibility? You can join by 12:30 in the other case. Because we don't want you to miss you this class.
yeah, I'll leave by 12:15. I'll finish this topic and leave for today at least.
No, what I'm saying today is okay, but you request from next class onwards whether you can reach to that class by 12:30, okay?
Okay, sir.
15 minutes, because you miss the last momentum of the class, then again next class when we continue, it will be a disturbance for you.
All right.
ठीक है ना? Sure. Hello, dears. Are you back?
Yes, sir.
Okay. Let's start now. So I was talking to you that slope is equal to speed. Basically, what is slope? What we understand by slope?
Gradient.
Radiant. Come, Vanshika, come again. I can't hear it.
Sir, gradient.
Okay. Anybody else? What is Dipenter? What is slope here? What can be slope?
So
Hmm.
slope is an inclined. So it can be an inclined plane.
Okay. Slope, and then we can write it as slanting. Slanting or inclined. है ना? Okay. Slope is basically we can give the synonyms like probably standing or inclined or something like that. Am I right? What is my point is here from physics. In physics, I am telling slope mean by speed. Okay. In physics, what I'm trying to tell you, I'm telling you slope is equal to speed. Okay. Will you agree with this with me? Can you agree this? How? How can we prove this? Hello.
When you're in an inclined or slanting thing, you go ahead and that's speed, something like that.
Okay. Okay. Let's see the same case. For example, in this x and y graph, am I right? X, y. Okay. 1 and 2, 3, 4. Okay. Again here 20 and 30. Okay. 40. Am I right? Okay. Let's say in this case, suppose this Boni, okay, this guy had gone to school 20 kilometer. Okay. School closed. School is closed. What has happened? School is closed and returned. Okay. Am I right? Oh, leave it. Not returned. She had gone to school 20 kilometer and again from the event next 1 hour another 20 kilometer to a mall after school. Okay. So the same thing. Let's see from here 1 hour 20 kilometer next 1 hour 20 kilometers. So total how much distance he has traveled? 40 kilometers he has traveled. Okay. Now let's take this slope. This area is the slope. Okay. Am I right? Yes or no? In trigonometry, how many of you are good at trigonometry? So in trigonometry, slope equal to, we say tan theta. What about tan theta? Hello? I'm mathematically proving slope is equal to speed. Okay? Learning physics through mathematics. Okay? Learning physics through mathematics. Physics is a subject where if you have some mathematical content in you, some mathematical calculations in you, physics will become easy. You got me what I'm saying? What I'm trying to prove here? What I'm trying to prove here? What we are trying to prove here? Who can tell me?
Slope is equal to speed.
Slope is equal to speed. Do you want to understand it or not?
Yes,
Would you like
sir.
to know? Would you like to know how slope can be speed?
Yes, sir.
That's what we are discussing. So this area is slope. Okay, let's take which area I'm telling. This area is slope. Okay, am I right? And this area is what? Base. Am I right? Base. Yes or no? Base only, na? Hello? Yes or no, yeah? Tan theta, can I write, is perpendicular by base. Tan theta equal to perpendicular by base.
So what do you
Have you
mean by
learned it?
base?
Base is the
This.
base of, yeah, in trigonometry, what is the base? What is the
Okay,
area of
okay.
a trigonometry? How do you identify area of a triangle?
1/2 into b. Okay, sir. Yes, sir.
So what I'm saying here, perpendicular by base. So what is perpendicular here in this case? Is it 40?
Yes, sir.
Is it 40? Base is how much?
2.
2. What is this gives you?
Wow. 20.
Speed. Speed.
Yes, sir.
It gives you speed. So 20 kilometer here. 40 by 20. Am I right?
Oh, yeah, got it.
So now you understood how to take a speed from a slope. Tan theta. Slope is equal to, okay, slope is equal to tan theta. Tan theta equal to perpendicular by base. So total perpendicular is what here? 40 divided by 2 hours. Base. Okay. So speed is equal to 20 kilometers. So slope is equal to speed. है ना? Slope gives you speed. Isn't it or not? Okay. So I will add here one word. Okay. Straight line slope gives speed. Straight line slope gives you speed. I can't see Yutika and Himani.
I'm sorry, sir. I didn't know my video was off.
Any doubt in this as of now? Who understood this well? Who all understood? Say yes or no to me.
Yes, sir.
Yes.
Yes, sir.
What did we do? From slope, we have taken the speed. Nothing but slope we have considered as tan theta. And tan theta is nothing but perpendicular by base. And the perpendicular is the total slope there, which is 40 kilometer divided by the base. Hana? Water may be the base. Understood? Yes or no, yaar? Okay. Now, who all can tell me till now what and all we have learned? I want each one of you to tell me one point.
So first,
Okay, I will start with Jay
first we
Simha.
learn
Wait,
about
wait, wait,
motion.
wait. Vanshika, wait. I'll start with Jay Simha. Jay Simha, tell me one point which you have learned from this class.
So motion.
Okay, motion means like what is motion mean by definition of motion?
Change in position with time. Change in position with time.
Okay, now I will go to Daksh. Daksh, 1 point of this class.
Frame of motion, sir.
Which one?
Frame of motion.
Frame of reference.
Yes, sir. Reference.
What is that frame of reference?
Motion of object is always with respect to frame
To
of
a frame of reference. Wonderful. Kaustu Krishnamurthy, 1 point. 1 point of this class.
velocity
Velocity?
and
Is velocity a scalar quantity or vector quantity? Kaustav,
vector.
are you sure? Are you sure?
Yes, sir.
Why it is vector quantity?
So it has magnitude, direction.
Magnitude and direction. Okay, now I'm going to Aditya. Aditya, 1 point. 1 point of this class. Aditya, I'm waiting for you. I can't hear, but keep your mic on. Yeah. Okay, some disturbance, I can't hear. I think he's speaking. I'll go to Dipender now. Dipender.
Yes, sir. So it's basically path length, which is distance of an object that travels from initial to final position. And path length is also the total distance. Then we also learn about displacement, scalar and vector quantities.
Wonderful. Other Aroda.
So we learned about scalar and vector quantities.
Come again once again.
Sir, we learned about scalar and vector quantities.
Scalar and vector quantity. Okay. So can you give me one scalar quantity and one vector quantity?
One scalar quantity would be speed, a vector quantity would be velocity.
Okay. And Vanshika, Vanshika, right? Vanshika.
Yeah, displacement motion is also linear and circular, also speed and slope. How to
Okay, very
calculate.
Very good. Avantika,
Yes, sir.
1 point of this class so far.
Scalar and vector quantity.
No, that's common. Everybody has told us something else.
Uh, rectilinear motion.
Very good. What is rectilinear motion?
Straight motion along straight line.
Wonderful. Nirav?
Circular motion.
Okay, good. Himani?
We learned about how to calculate slope by using a distance time graph and how trigonometry is related to
So
finding.
learning physics through mathematics. ठीक है ना? Next, Yutika. Yutika?
We did physical quantities,
What are the physical quantities?
path length and displacement.
Okay, Aditya. Aditya already told me. Okay,
His audio is not working.
Okay, Meera.
Sir, displacement.
Okay, very good. See now, next point in this, like I'm going to give you a position time graph. No one had told me. No one told me distance time graph. Okay, we have learned one graph already. Distance time graph. This is position time graph. What is this? Position time graph. So we have x.
So can I leave the class?
Okay, but next class only you should ask and stay back. Okay. We can't permit you this. Right. So next is position time graph, and you keep learning this from your friends. Okay. After the class, you ask them what did I teach them or what was the class. Next 15 minutes. Okay. You try to copy the notes if possible. ठीक है ना? चलो. So position time graph in this x-axis will be always what? Time. Okay. And this is position time position. Position. Okay. In this y graph, we have y-axis we have and x we have. Here again, I am mentioning 1 hour, 2 hour, 3 hour, 4 hour. And this is first 10 and 20 and 30 and then 40. So what is this 10, 20, 30 and all? Kilometers. Okay. Understood? What we are trying to learn here? Position time graph. My dear, position time graph, distance time graph and all is very important. In the examination, when I give you physics test, I will ask this graph. Okay. I'll be asking questions based on this graph in the test. When I give you the test. So please note it down perfectly. So position time graph is the x-axis and y-axis. In the same case, suppose I tell Boni had gone to his school, all right, which is 20 kilometers away, and school closed. Okay, school closed. He returned. Okay, he returned. How do we draw this graph? Can anybody draw and show to me on the screen? Yeah, Meera
So
will
it
show.
will be like a hill.
No, show. Draw and show me. Show me on
How
the
do I
camera.
show, sir?
What is the question?
Show me. You can draw on or not and keep the camera
What
towards
do we
your,
have to do?
towards your camera. I'll be able to see from here.
So what is the question?
Question
Which-
is that like position, this is position time graph. So I'm telling Boni, a student gone to 20 kilometer away school. Okay, he is gone to a school for 20 kilometer and school is closed. He returned. Show me the position time graph.
So what is the time taken to go there and come back?
1 hour. First 1 hour. He took 1 hour, 20 kilometer per hour. 20 kilometer per hour. I said 20 kilometer per hour. 20 kilometer.
Sir, in 1 hour he travels 20 kilometers.
20 kilometer, which is that is the school, and the school is closed and he returned. Now show me the position time graph.
Something like this. Something like this.
Little more closer here.
I did write this.
No, Daksh, no, Daksh, no.
This one.
Think little bit. Who's that? Meera, wonderful, yeah, super. Meera is good. Happy about you, Meera, super. And who else? Who else? Don't show to them anywhere. Show to anybody now. Let me see. Anybody's got the knowledge. Yutika, Aditya. Where is Avantika? Avantika, what is happening to you?
Yes, sir.
Show me the graph.
Yes, sir.
Arthur, Jaisimha. Meera is good here. Meera, keep up that same hard work. Try learning as it is. Daksh is also trying very good. Daksh is okay, Daksh. Okay, little bit. It's okay. It's okay. It's okay. I think I don't know whether you've seen from Meera. I do not know. You've seen her? No, she's sitting very far away from you. Okay, then good. Good. Super. Super. Good. So what is happening here? Okay, all others are not okay. You have to learn a lot. Okay, you have to learn a lot. Okay, Avantika. See, what is happening? What did I say? 20 kilometer, first 1 hour he went 20 kilometer. Okay, this is the school position. Next 1 hour, okay, the school is returned, so he takes back to home. Which means this is the graph line. Straight line, you draw it properly. I said from here to this and return 20. You got me? You got me? So what is happening? Here return back, okay? Return back position, because he has returned back to the original position. This is the original position. Which is the original position? The 0 is the original position. This is the original position. So he has gone to 20 and he returned. So what is the displacement here? What is the displacement?
Zero, sir.
Displacement is 0. Velocity? Velocity
is also 0.
Wonderful. When velocity is 0, displacement is 0. When displacement is 0, velocity will also be 0. Okay. Am I right? What is the path length? Distance?
If velocity is 0, displacement is also 0, right?
Correct.
The
So what is the path length? What is the path length?
40, sir.
Path length is what?
40.
Path length 40.
Sir.
Good. Understood? In this case, displacement is 0 because he has come back. Velocity is 0, he has come back. Now I'll tell you one big example. Suppose you are sleeping at your home. Okay. When your father is going out, you are sleeping. Okay. Which means he has gone out by 8 o'clock. Right? He has gone out. You were sleeping on bed and he has gone out. Now 8:30 you got up and went to the school. Okay? 8:30 you got up and went to the school. 9 o'clock you reached to home, school. School is closed. By 9:30 you return back to home and you are still on the bed. Okay? Now your father came back by 10 o'clock seeing you. According to him, displacement is
0.
0. Velocity is
0.
0. According to your path length?
With path length will be 40, 50, whatever.
40. Understood now? Correct now? Clear? Isn't it? Is that clear?
Yes, sir.
Okay. The next small topic. Okay. Are you all with me? Are you all with me? I'm asking. Okay. Next is
Yes, sir.
Yes, sir. Yes, sir.
uniform and non-uniform motion.
Yes, sir.
What is
Same,
this uniform and non-uniform motion? Yeah, that's
same time, same distance, same time, different distance.
okay. For uniform motion, please do write a small definition. Kindly write. I'll tell you now. All of you are with pen and paper. Uniform motion. Yeah, good. Those are all with pen and paper. Super. Do it. A body is said to be. Please do write. A body. A body is said to be in uniform motion. Avantika, are you not writing? A body is said to be in uniform motion. A body is said to be in uniform motion if it covers a body is said to be in uniform motion if it covers equal distance in equal intervals of time. Equal distance in equal intervals of time. A body is said to be in uniform motion if it covers equal distance in equal intervals of time. So, non-uniform motion, please do write. Unequal distance, non-uniform. Non-uniform motion. Unequal distance in equal intervals of time. Arthur, are you not writing? Unequal distance in equal intervals of time. Unequal distance in equal intervals of time. Hannah? Both you understood? All right. Okay. So next small topic of this motion is in motion. So far, so many identities we have learned. Okay, so many subtopics we have learned. Which are all subtopics? Speed, velocity, uniform motion, non-uniform motion, slope, and then we have learned we have learned what and all? Neera, which are all the subtopics? Can you tell me all the subtopics till now we have learned in this topic?
So first we learned what motion is. Then we learned about like the reference point, like the relative thing.
No, I'm asking you the bullet points. Bullet points.
Frame of reference.
Frame of reference.
Then speed.
Velocity.
Distance time graph, velocity.
Velocity.
Displacement. Yeah.
Then
right now we learned velocity time.
Okay. Now the next small point is average speed. What is average speed?
Divide by 2.
What is divided by 2?
Total this.
So like the average rate traveled.
No.
The total distance by the total time travel.
By 2 also.
Now, average speed in uniform motion. Okay. In uniform motion, what will be the average speed?
Average.
It'll be the slope.
Average speed is what? In uniform motion, it is easy. Total distance. Given time. Am I right? In uniform motion, average speed is total distance by given time. Am I right, my dears?
Isn't average speed
total time? Yeah, total time. Given time or total time? Okay, given time is basically what? The total time given by. Okay? Kaustubh, what is happening? Sorry, Dipendra. Who's talking to me?
Daksh.
Daksh, tell me.
Sir, is average speed and normal speed is equal? Are they
yes.
equal?
Yes. Average speed, but you have to consider two conditions here, Daksh. Normal speed means what actually? The uniform motion. But in non-uniform motion, average speed varies. Okay. Understand? Suppose you go from Ooty to Coimbatore, so you are coming 1 hour in Mettupalayam, next 1 hour to Coimbatore. Okay. So 2 hours. So in the first 1 hour you have reached to Metropolitan, next 1 hour you have reached to Coimbatore. Both are, let us consider 30 kilometer or 25 kilometer. Okay. From Ooty to Metropolitan 25 kilometer, from Metropolitan to Ooty 25 kilometers. So both you have traveled in uniform motion. Both are total distance divided by total time. But till Metropolitan 25 kilometer you have come in, let's say 2 hours. And the next 2 hours, next 1 hour you have reached to Coimbatore, which is non-uniform motion. So in non-uniform motion, what is the average speed? How do we take average in non-uniform
Total
motion?
distance by given time.
Distance will be same, but the time will differ.
How can we do that?
Sir, I
Like,
forgot.
if the
I'll just
speed
learn.
increases, the time will go less, and if the speed decreases, then you will require more time.
So this is basically uniform motion. We can understand. Okay, in uniform motion we are able to understand actually total distance by total intervals of time. Am I right? Okay. But when it comes to non-uniform, this has to go total distance by given time. How it is? Basically, let us consider this way. Okay. Average speed in non-uniform motion. Okay. Suppose you have to travel. What I would say. I would say like first 1 hour and second 1 hour, third 1 hour, fourth 1 hour, and fifth 1 hour. Let's see 20 and 20 and then 20, then 20, 20. Okay. So 5 hours, 20 and total is about 100 kilometer here. Am I right? Am I right? In this, if a vehicle is traveling, okay, every 1 hour, 20 kilometer, that is uniform motion, and taking an average speed, total distance covered by the total time given. Am I right? Average speed can be taken. In non-uniform motion, what you will do? If a vehicle is traveling, how do we do?
It can
Suppose,
take 30 kilometers.
suppose if it is first hour 10 kilometer, okay. Second hour, if it is 30 kilometer, third hour, if it goes to 40 kilometer, fifth hour, if it is 0 kilometer, okay. Sorry, fourth hour is 0 kilometer. What I said, fourth is 0 kilometer, fifth hour is another 20 kilometer. So average speed, how do we take in this?
Non-uniform.
How can we take? This is non-uniform motion, no? Yes or no? First 1 hour he has gone to second 1 hour 30 kilometer, third 1 hour he has gone to 40, fourth hour he didn't go anywhere, he was in rest. Okay, fourth hour he has to take and rest, fifth hour 20 kilometer. In this case, how do we take average speed? Total
So we
distance.
add all the values and
total
we divide it
distance.
by time.
By
The total distance by total time.
so 5 hours. Am I right? 5 hours, isn't it? Yes or no, my dears? The total time taken.
So average speed is equal to?
So it's 2
Average
hours,
speed
right?
is equal to, in
2 hours.
non-uniform motion, total distance by total time.
Okay.
Okay,
And in uniform?
understood. Uniform motion, anybody can tell, na? Very easy, right? Uniform motion, every 1 hour it travels so and so timing, and the total we can take it in that way. What actually? Uniform motion, mathematical total distance covered in a given time.
So for
Uniform,
both uniform and non-uniform, it's the same thing. The formula.
but you have to calculate it a different way here. Okay. The total distance you have to take it, and then the total hours taken here. And the other way, actually, if you take it in a particular intervals of time.
So can you show the example?
For non-uniform motion?
Yes.
No, non-uniform motion, this is what I said. Suppose a car is traveling first 1 hour 10 kilometer and second 1 hour 30 kilometer, third 1 hour 40 kilometer, fourth hour is rest. Okay. and fifth hour again 20. So total here 100 and divided by 5 hours.
So that
100.
and how do you calculate that?
Which one?
How do you calculate the non-informed thing?
So 100 divided, so that's what, total kilometer traveled by total hours. How much hours has taken to travel that distance, the covered distance. The number of distance covered by the number of the total number of hours taken. Because even if your fourth hour is 0, still we have taken 5 hours.
Yes.
5 hours. Okay. Suppose this is 6th hour. Okay, 20 kilometers. Then it has to be 6 hour. Okay? Understood or not? So average speed is over. Next is average velocity. In the next class, probably we'll see average velocity. I've not come up with today the what you call PPTs and all those things. But next class, probably we'll have little more PPTs also to understand the animations or some areas little bit. You can have a clarity. Next class of motion, I'll come with one more one PPTs. Okay, so that you will be able to take little more notes or screenshot or something like that. But today, motions till average speed we have understood. Now average velocity is the, after that numericals will start. Okay, or if time permits, I'll finish it off average velocity today, and next class numericals we'll do. What is to be done?
Next class, sir.
We'll do next class, or we'll finish one more topic, average velocity. Should we? Or next class? Okay, next class. So till now, whatever I have taken, see to that the notes are with you, and take notes. I won't be telling you keep writing down, etc., etc. Keep the notes because you are all grown up. You know which are all to be taken down, and those things you take down, understand, and practice. See, basically, I said physics is for those who are not mathematically fit. For them, physics will be a boring subject. So someone who are a little bit strong with mathematics, who are working with mathematics strongly, physics will be easy for them. And understanding physics, you need to understand the concept behind each point. Okay, take physics to lively. So physics, understand physics from your surroundings. Understand physics from your surroundings. Where you are sitting on a chair, that chair is also got a physics. Okay, what physics is there in that chair? What physics is there? Balanced force. Balanced force. Am I right? Balanced force, gravity. Am I right? Yes or no? One leg is cut. That chair, one leg is cut means what will happen? From 4 leg, one leg is cut. If the one leg is cut, balanced force will become unbalanced force. Am I right? Yes or no? Okay? So understand physics from your surroundings. Relate that physics to your regular works, regular studies. You'll be learning better. Now in football, physics is there. Yes or no? Likewise, learn physics. Understand, you drinking a glass of water, that is physics. If you drink a glass of water, physics is there in that glass of water. Okay. So everything, relate that physics into a regular life, physics will become easy. And slowly, slope is equal to
y2 minus y1 upon x2
slope is equal to
speed.
Speed is equal to tan theta, which is perpendicular divided by base. Yes or no? So from slope, we can see if somebody tells you, can we get a speed from a slope? Yes, speed can be derived from slope, isn't it? Perpendicular divided by base. Okay? So thank you so much. We'll see you in the next class. Okay?
Sir, thank you, sir. Bye.
Yes, sir. Bye, sir. Thank you, sir.
Bye.